In this lecture, we will talk about graphs of sine and cosine. Before we do that, you probably want to review, in the market, these two popular triangles. The first one is like this. Here is 30 degrees, or you may say here is 30 degrees. Here is 60 degrees. Together is 90 degrees. And here is 90 degrees. Right triangle. For a 30 degrees angle, the opposite side is half of the adjacent, the hypotenuse. Okay, and then this longer leg is radical 3. If this side is 1, then we got this side is 2. This one is very popular one. Help us to remember 1, 2, radical 3. Of course, you can divide everyone by 2, so if here is 1/2, here is the double length of this one, and then this side will be 1. 2 divided by 2 is 1. Radical 3 divided by 2, you can just leave it. Okay? This is a popular one. When you see you go to Office Max, you should always remember this one is half of this. Okay? This one is half of this one. This will tell people that you have learned trigonometry. Okay. Now, this is 45 degrees. This is another 45 degrees. Okay. And this is an isosceles right triangle. And this is 90 degrees. If here is 1, this leg is 1, then this leg will be radical 2, not 2, okay? Yeah, if it's 2, here is 1, here is 2. If here is 1, here is 1, this is radical 2, okay? Remember that, because 1 squared plus 1 squared is 2, and radical 2 squared is 2, so add the squares of those two will be equal to the square of the hypotenuse. You always remember that. And then divided by radical 2. Why do we need to do that? If you want this hypotenuse be 1, you want to divide radical 2. So radical 2 divided by radical 2 is 1. If this side is 1, then this side is 1 over radical 2, and this side is 1 over radical 2. Okay? And so is the case right here. If you want this part to be 1, you divide it by 2. Because 2 divided by 2 is 1. They are different. Okay? And 1 divided by 2 is 1/2. And here radical 3 divided by 2 is, leave it like that. Yeah. This is very important for us to remember to proceed. Okay? Now, today's lecture is like this. Let's look at this picture. This picture looks very complicated, but actually it is not. Okay? If you look at here, pi over 6 is how many degrees? Pi over 6 is 30 degrees. Remember that. Okay? Pi over 3 is how many degrees? 60 degrees. They are opposite. Okay? If here is 3, here is 6, because pi is 180 degrees. Alright? Yeah, 180 divided by 6 is 30. 180 divided by 3 is 60. Okay, and here is 45 degrees. Okay? 180 divided by 4 is 45. So that's why those two rulers are important. Okay, look at this one. If here is 30 degrees, if t is 30, then it tells us here is 30 degrees. Here is 30 degrees. Then this leg is half of the hypotenuse. So then down here, this leg will be half of the hypotenuse. We know this is a unit circle. The radius is 1, from here to here is 1, from here to here. Yeah, everywhere is 1. So if this side is 1, this side is 1, this side has to be 1/2. That's the reason. This side is half of this one. Or you may say this side is half of this one, because this is 30 degrees. Okay? So it's not hard at all. And then we know the x coordinate is from here to here. That's radical 3/2. That's this from here to here. And y coordinate is 1/2, because this part is 1. Okay? Alright. Now, here is from this point, pi/4. Then pi/4 is 45. Then you know here will be 45 degrees. If you can draw another one. I'm not going to draw it. If you draw it, you will know if here is 1, then this leg is radical 2/2. This leg is radical 2/2. So basically it tells us xy coordinate is radical 2/2, radical 2/2. For x, both x and y. This is the reason you want to look like this. Okay? Yeah. Now, this pi/3, 60 degrees. 60 degrees, it tells us from x-axis to here, to here is 60 degrees. Or you may say from here to here, the length of the arc is pi/3. Okay? So, then you know you want to look at the picture in this way. Alright? You see, if you draw a straight line, then here is 90 degrees, here will be 30, and this one will be 60 degrees. Then again, if you look at this triangle, this will be half of this one. So x coordinate will be 1/2. So that's why we have 1/2 here. And then y coordinate will be radical 3/2. The reason is right here. Radical 3/2, this part, if here is 1, and here would be 1/2. Okay? So we are clear about x coordinate. Okay? 1/2, radical 3/2, radical 2/2. Y coordinate. Yeah, you can see down here, y coordinate is 1/2, then radical 2/2, radical 3/2. So with this point, it's getting closer to pi/2. Your y gets bigger and bigger. You see y gets longer and longer. But x gets smaller and smaller. X was that. And then, you know, radical 3/2 is 0.7 something. Okay? Right? Divided by 2 is 0.7 something. And radical 2 divided by 2 is 0.7 something. Here is 1.7 divided by 2 is 8 point something. Okay? And here is 0.5. Okay? You can use your calculator to find out. And then this one is 1, 0, this point, 1, 0. And this point is 0, 1. Okay? Now, we are clear about 1, 2, 3, 4, 5 points. And then, if you look at here, that's pi/2 plus pi/6. You see this amount is pi/6. So you add, this is this angle is pi/2, so this is pi/6. Then pi/2 plus pi/6 You times 3 on both numerator and denominator. 2 times 3, you got 6. And upstairs 3 times pi plus 1 times pi. So you have 4 pi over 6. Okay, you reduce it, that's 2 pi over 3 down here. And those 2 points are symmetric. And then y coordinates would be the same. Okay, and then y coordinates is sine. So sine these 2 angles would be equal. Okay, yeah, sine pi over 6 plus, you may say sine pi over 6 equals sine 2 pi over 3. Okay, because, right here is pi over 3. So sine pi over 3 is radical 2 over 2 equals sine 2 pi over 3. Okay, yeah, because y coordinates are the same. Y coordinates are sine. But x coordinate is different now. X coordinate here is 1/2, here is negative 1/2. Okay, those 2 points. You see, these points and these points. Y coordinates are the same. X coordinates, one is 1/2, another is negative 1/2. So you may say cosine, because x coordinate is cosine, cosine pi over 3 equals 1/2. And here cosine 2 pi over 3 equals negative 1/2. Okay? That's the reason, because cosine is x. Alright, keep going. Those 2 points are symmetric. Okay? And it's easy to find out, from 45 degrees, 90 degrees, another 45 degrees. Okay? Then how did we get this number? That's pi over 2 plus pi over 4. Okay? You see 2 times 2, and here is 1. Pi over 4, remember, is 45 degrees. Pi over 2 is 90 degrees. So you can see from this is 0 degrees, 45, 90. This is 90 plus 45 is 135 degrees. Okay, so 3 pi over 5 is 135 degrees. Okay, 135 degrees is 3 pi over 4, because here 2 plus 1 is 3 pi, and then we have a denominator is 4. Okay, so those 2 points are symmetric. Since they are symmetric, you have x coordinates are opposite, radical 2 over 2, and then y coordinates are the same, radical 2 over 2 positive, and here is a negative 1. So you may say sine pi over 4, y coordinate still are the same, radical 2 over 2, so sine pi over 4 equals radical 2 over 2, y coordinate, and sine 3 pi over 4 is still radical 2 over 2. Okay, sine is y coordinate. Alright, cosine will be different now. So cosine pi over 4 is radical 2 over 2, but cosine 3 pi over 4 is negative radical 2 over 2. That's the reason. Okay? Now, again, this point will be symmetric with this point. And here is the reason. Here is the reason. You see, you actually from here to here is 30 degrees. From here to here is another 30, so you get 60. From here to here, you have a 90. From here to here, another 30. From here to here, another 30. Okay? Or you may say, from here to here is 30, from here to here is 30, so you get 60. 60 is pi over 3. Pi over 3 from here to here. From this angle is already pi over 2, or 90 degrees. So 90 degrees plus 60 degrees. Or you may say pi over 2 plus pi over 3. Pi over 2 plus pi over 3, you add together, you see this is the way. Make the denominators be the same. Numerator times 2, denominator times 2, numerator times 3, denominator times 3. 2 plus 3 is 5. Denominators are the same, so you keep it. You only do numerators. That's 5 pi over 6.